following scatter plot. Is that okay? And then we are asked to find which is which. So it means that we want to match distance to the correlations here. Does that make sense? So what do you think is the easy one? So I've always told you, whenever you are faced with this, let's do the easy ones first. Is that okay? What do you think is the easy one? I find 3 to be the easiest one. So when you look at 3, which of the following correlations do you think matches 3?
Negative 0.938.
Do you all agree to that? You all agree to that? Okay. So let's put A for 3. Because that is A, isn't it? Okay. So if A is for 3, easily we can see that we have eliminated A to C. Can you see that? Because we know that 3 is A, but from A to C, 3 is D, C, and D. Can you see that? So you have quickly eliminated A to C. Now, what is the easier one again?
Maybe 2.
Okay, 2. What do you think 2 should be?
It should be 0.787.
Okay, so that means 0.787 is D. So 2 is D. So you see now 2 is D, that eliminates E2. Can you see that? You can see that now because 2 is D, it has eliminated E2. So you can see, then we do it for D. So this is how to be able to move fast. Is that okay? And then you could also, when you look at this, we are left with what? B and then C. So we can quickly see that 1 is C, isn't it? And then 4 is 4 is B. 1 is C because we know that for correlation coefficients, it's purposely for linear. So these are some of the easy ones. So I always recommend that try to get the easier ones first, and then you can eliminate most of the possible answers. Does that make sense? Any question on that? Okay, let's skip to the next one. So we've done this one. Just let's get to the second one. So the second one is just trying to ask you about the definitions of all these. So for example, we know a census is everybody. Is that okay? And then the population is also like everybody. And then the sampling method is, for example, are we doing stratified sampling, cluster sampling, simple random sampling? And then the population parameter of interest is what you are interested to estimate. And so when we look at this problem here, we are told that a publisher magazine will mail a survey to 12% of its subscribers. So it means that you are mailing to some of your people, and those people will be chosen at random. And this is what the survey asks about the quality of its subscription service. And then we also told that all of the subscribers who have an equal and random chance to be chosen for this survey represent us. So that represents the what? The sampling frame. Is that okay? So that is easier to spot. Now let's proceed.
So the people like chosen at random are part of the sampling frame.
Yeah, so the sampling
Okay.
frame is like, yeah, the people. And let's get to the next one. So the next one is trying to ask you which type of sampling technique was used. So we are told that a college has 120 freshmen, 90 sophomores, 110 juniors, and then 80 seniors. So then the school administrator select a random sample of what 12 people from the freshmen, 9 from sophomores, 11 from juniors, and then 8 from seniors. And then she interviews all of the selected students. So you can see the group or the strata is whether you're a freshman, you are a sophomore, you are a junior, or you're a senior. And when you look at all these, for cluster, it means that, for example, we just choose, are we taking sophomores or juniors? When we take any of them, we are going to interview all of them. But the stratify says that we pick some people randomly from each group and then we interview them. So when you look at this one, E is the best answer for this type of sampling. Now let's get to the next one. We are given a table and then we are asked to determine whether this probability assignment is legitimate or not. So last time we learned about 3 things. Do we have any negative probability here? No. And then if we don't have any negative probability here, we know that what? The sum of the probability should be equal to 1. Is that okay? So when you sum all this, what do you get? 0.90. This is not 1. Is that okay? So we can see that what? It is not what? Legitimate. And then let's do the other one too. We also have this probability. We want to determine whether it's legitimate or not. So we look at the probabilities here. There is no negative probability. Let's try to sum all of them and see if we are going to get 1. So when you sum them, what do you get?
0.45 plus 0.15 is 0.60, and then 0.25.
So if that is 1, it means that this is what? Legitimate. Is that okay? So if I first try to look at if I'm going to get any negatives, the next step I do is try to sum all of them if I'm going to get 1. If it's more than 1, it's not legitimate. If it's less than 1, it's also not legitimate. Does that make sense? So we have done this and this too.
So what is the definition for disjoint again? I keep like having trouble with that. Like, what does it mean when they're disjoint?
So when they are disjoint, it means they have nothing in common.
Okay,
So it means that their intersection is 0.
okay.
Yeah. And so here, the last one says that we should determine whether the events are disjoint, independent, neither or both. And so here we are flipping a coin twice. The event of getting heads on the first flip and heads on the second flip. So it's independent because when you flip and you get head, you can flip again. You can either get head or tail. The first one doesn't, whether you're going to get head or tail, is not dependent on the outcome of the second one. Does that make sense? So then that is what? Independent. So we are done with this one too. So I want you to work this one out. We are given a contingency table that provides a joint frequency for the distribution of a sample patient at the hospital classified by the blood type and then the sex. I think so. I think the table wasn't well structured, but the 74 should represent the M row, and then the 175 should represent the total. Does that make sense? So like female 101, and then the nurse the next row the male should be 74, but it looks like it's on the line. So you should try to fix that. And then the total is 175, 167, 38, 10, and then 390. So then the question is asking you, if a person is selected at random from the sample, you should find the probability that the person has blood type B. How do you find that?
The 38 and for the total of people and a B type of over 390 for the total of all people selected for.
That's correct.
0.097.
Yeah. So we are looking for the probability that the person has a blood type B. So when you look at this is blood type B. This is blood type B column. What is the total people for blood type B? It's 38. Is that okay? And then you divide by the total population, which is what? 390. And then you get 0.097. So we've done this one too. Okay, so I want you to try the next one. You draw a card at random from a standard deck of 52 cards. Find the probability that a card is spade given that it is not diamond. So what are we looking for? We are looking for what? Based on this information, we are looking for the probability that what? It is spade given that what? It is not diamond.
What is this called again? Is it conditional?
Yeah, that is
probability?
conditional probabilities.
Okay.
So how do we go about that? How many types of cards do we have? How many groups do we have? We have 4, isn't it? I provided you with those list as well. If not for this lesson, then I think chapter 13, I provided you with those lists when we are dealing with the conditional probabilities. So we have club, spade, diamond, and then hearts. Is that okay? How many total number of clubs do we have?
13.
13. Spades, diamond, and then hearts, 13. Is that okay? Good. And so if you are looking for the probability of spade, given that it is not diamond, this is the probability of what? Spade, given that not diamond, is going to give us probability of what? Spade and not diamond, divided by the probability of what? Not diamond. Does that make sense? We already know the definition for these conditional probabilities. Is that okay? So, what do you think is the probability of spade and not diamond would be? So we are looking there for the probability of what? Spade and not diamond. What do you think that would be? That is going to be 13 because this is spade and it's not diamond. Is that okay? That is 13 over what? 52. Does that make sense? So that is 13 over 52. Now let's look for the probability that it is not diamond. Probability that it is not diamond, what do you think is going to be? So it means that we are going to add everything here and exclude diamond. Yes, 39 over 52. Does that make sense? Not diamond, we are going to add everything here and exclude diamond. Is that okay? So 13, club, spade, skip this one and then add hearts. That's going to be 39. 39 over 52. So now that we have this, we can just plug this in here. So 13 over 52 divided by 39 over 52. When you use your calculator to compute, what do you get? When you use your calculator to compute, you are going to get you are going to get 13 over 39, which is 0.333. Does that make sense? So that is how to do for this stuff. So the most important thing is that you should be able to know whenever you have a standard deck of 52 cards, how many claps do you have, how many spades, how many diamonds, how many hearts, how many face cards, how many ace. I provided all those informations to you. And then the rest, you could just look at what you are looking for, and then you can solve that.
So what does the like right side up and the upside down like U symbol mean in this again? One means like and, right?
So this one means or,
Okay,
this one means and.
okay. So right there, we were using like spades and not
Yes, spades and
which
not
is still
diamond.
just any of the spades,
Yes, because spade is not
right?
diamond.
Yeah, okay,
Yeah.
okay,
So and means it has to satisfy both of them.
okay.
That is why we didn't choose club, because club is not a spade. We are looking for spade and not diamond. Is that okay? It's like we are looking for a student, and the student has to be an upstate student. So we could see other students, but they could not be upstate students. So we are not going to focus on those ones. So you have to meet those two conditions. You are a spade and not diamond. So it's the same as you being a spade, because if you're a spade, you're not a diamond. Is that okay?
Yeah.
Good. Now let's get to this one here. Let's try to write this information down. We are told that a group of volunteers for a clinical trial consists of 80 women and 79 men. 17 of the women and 18 of the men have high blood pressure. Then the question is that, are high blood pressure and gender independent? So for me, to be able to answer this question, first look through the possible answers that you have. Is that okay? So what do we know about independence? Last time we learned that to show that something is independent, you could go through your note. I wrote that probability of what? A given B is equal to probability of B. You could look through your notes or the recorded lectures that is available on As You Learn. So we have this, we know this to show that something is independent. This is in our minds, or this is on our sheets. So when we look through these things here, it means that we are going to focus on either B or C. Does that make sense? You have to be able to be smart to save time. Is that okay? So when we look through this, I'm trying to go and focus on either B or C. So to be able to do that, let's try to find the probability of high blood pressure. So to be able to do that, what is the total number of people do we have? 159. It is 80 plus 79. Do you agree to that? Okay, so probability of high blood pressure is going to be what? What do you think that is going to be? It's going to be 17 plus 18. Is that okay? Which would give you what? What is 17 plus 18? 17 plus 18. 35 over 159. So this is what? 35 divided by 159. When you do that in decimals, what do you get? Because our answers are in decimals. What is 35 divided by 159? Okay, 0.22. Okay. So that is the probability of high blood pressure. Now let's try to find probability of what? High blood pressure, given that the person is a female. Is that okay? So to do this to find this means that probability of what? High blood pressure and female divided by a probability of what? Female. Does that make sense? So, or we could also put the numbers here. It's going to be the same thing. So how many people have high blood pressure and then they are females? 17. How many total of females do we have? 80. Or I just decided to do the numbers because even if I do, this is going to be 70 over 52, 80 over 52. The 52 is going to cancel. It's the same thing. Is that okay? What do I mean by that? I mean, probability of high blood pressure in female is the same as 17 divided by 52. Females is 80 over 52. 159, my bad. Let me clean that. The 159s will cancel. So you are still left with 17 over 80.
How did you get the 17 over 8 right there?
Okay, the same thing. I'm looking for probability of what? People with high blood pressure and they are females.
Oh,
and
okay,
so,
okay.
or they are women. So
Okay, so
that is,
I got it. For
17.
some reason, I thought that was like men and female up there, and not high blood pressure and female. I don't know.
Yeah. So this is what? 70 over 80. So what is 70 divided by 80? Okay. So this gives you 0.2125. Okay. And so based on this that you have written on your sheet, it means that probability of what should be equal to probability of what? H. And then when we compare this one and then this one, they are not the same. Is that okay? Can you see that? They are not equal. So if they are not equal, they are not independent. Now, let's try to look at B. B, to show that they are independent, we are not going to compare these two. This is the approach. Is that okay? So if you are using high blood pressure in female, should be equal to probability of what? High blood pressure. That is why we are focusing on what? C. Does that make sense? Or you could also try to do the probability of what? High blood pressure and then male 2 and C. When you do that, I don't think you are going to get 2132 as well because the numbers are different. So that is how to answer that. I think our time is up. So we'll continue this when we resume from spring break. So spend time and do them by yourself so that when we are doing it, we could go fast. And when you have questions, I could answer them.
When we get back, we'll have a Monday and a Wednesday review, right? And then a test on Friday.
I think the test it's on Wednesday.
Oh, okay, so we'll just have one more review.
Yeah,
day?
one more review.
Okay. And could you remind me again, like what chapters is it through? Like,
I'll send an email probably tonight or on Saturday.
okay. I'm gonna work on stuff on the spring break and
Okay.
I might get my exam sheet to go.